This is Mantaya. So, um, this is going to be a video about graphs. And the first problem we're going to deal with in graphs is known as the number of components. And let's see what that means. So, for function, and let's give it the name comps, which is short for components. Okay, so we need n, which is the number of nodes, and we need the second argument would be edges. Okay, that is basically a list. Well, it's an array. Okay, think about it that way. So we need a result array. Oh no, sorry, we don't know. We need an adjacency list, ADL, short for adjacency list. We need a visited. We don't need to, it can just be an empty array for now. Let's not worry about true or false. I will explain that in a bit. And we need a count, which actually is what we will be returning at the end of the function, right? Because we're trying to find the number of connected components in the graph. Okay, and set it to 0 for now. Okay, first thing we need to do is we need a for loop I equals 0 and always increment, right? I here will be less than n, okay, which is the number of nodes in this context. So ADL I equals an empty array for every node. Okay, second for loop we need, and that will be to populate the adjacency list, and I will tell you I won't tell you actually. I will show you what that means. So let's go I equals 0, again increment, and I this time because we want to deal with edges, right? So this I will be less than the length of edges. Very simple. Okay, and this is where I know it will look confusing, but I will try to make it as clear as possible. Okay, so ADL and then dot push. Let me type it and then I will do the explanation. Push. Okay, perfect. Well, there we go. So here what we want is edges I 0 and edges I 1, and now the reverse, edges I 1, yes, and edges I 0. So you might be thinking, what is going on? That's fair. I had the exact same question when I was dealing with this for the first time. I was spinning around this. I couldn't figure it out, but it takes a while to truly understand these problems. Keep in mind, these are not simple problems. Graphs, I think, have the toughest code when it comes to computer science and algorithms and data structures. Graphs look easy, but they're not. Trees, in my opinion, on the other hand, they look confusing, but trees are super awesome to deal with. That's just my preference. But anyways, let's get going on. So adjacency list, right? Forget the edges I0, I1, or in this case I1, I0, right? What does an adjacency list mean? What that means is you have a key. Your key is a node, right? And the value is an array of the neighbors of that given node. That's all an adjacency list means. Okay, and here we need a function, which is DFS in this case, and let's let's call this a node. Okay, I will get back to coding this. Let me write the full structure, yeah, because that's going to help me and all of us. And in the end we return count. Yes. Okay, so what we are doing is in the end we run a for loop, and in this for loop we will use this DFS. So I here is less than n again, and this is where the visited will come into play. So if I is not visited, count, increment the count and run the DFS. That's it. That's all we have to do. So and now let's deal with the DFS function. Okay, so here we say visited node equals true. We set it to true. We can set it to 1 and 0 as well, but you know, it's up to you whether you want 1 and 0 or true and false. And then we run a for loop. Okay, let I, oh no, not let I. So what do we need? Right, so any of ADL node. So keep in mind we have this node, we're starting with this node, but we also want to deal with the neighbors. So this any is short for neighbor, and we're looking at the neighbors of the node, and we're referring to the adjacency list again, because remember we populated the adjacency list here. And if you don't understand this, that's okay. Keep practicing, keep coming back to this video, and try to I know it's painful, but try to manually go through this code and write out the arrays and the values and see what each line does. It will help you, believe me. Okay, so yeah, we're dealing with the neighbor of this node, and what if if it's not visited any, then all we have to do is run the DFS on the neighbor. That's it, simple. So if the neighbor of the node of is not visited, we just run DFS again, because what is this DFS doing? It's basically marking the node as visited or not. That's what it's doing. All right, and there we go. It's 30 lines of code, and hopefully this works. 5 and edges. Right, so it's an array of array. we have 0 going to 1, 1 to 2. Perfect. So there we go. It's working correctly. So we have one edge going from node 0 to node 1, and then another from 1 to 2. The third edge is from 2 to 0, and a fourth edge between 3 and 4. But you can see that 0, 1, 2 are connected, and 3 and 4 are connected by an edge. But this is not, 3 and 4 are not connected with nodes 0, 1, and 2. So that's why they're two different components, and that's why the answer is 2. And keep in mind, 0, 1, and 2 here, they form a cycle. And sometimes it's okay to have cycles, and sometimes in cases where you're dealing with topological sort, you don't want cycles. Just keep that in mind. It's good to know, and you don't need to worry about topological sort today. I will cover that in one of the videos to come. Thank you so much. Please support my channel. I'm doing this for you all. I want people to feel that they belong in the world of computer science. I don't want anyone to feel lost. I really, really mean this, because I have been through all that. I'm working hard for myself and for you all. So please support me, like, share, subscribe. Thank you so much, and have a fantastic day.